Hello and welcome back to the geometry video page. So today I'm going to be proving some proofs. I'm going to be proving that triangles are congruent. Okay, so as you can read, when you are trying to prove that two triangles are congruent, you need to show three things from both triangles are congruent. Okay, three corresponding things. If you show one angle, it has to be the same type of angle in the other triangle. So remember, there are 5 different ways that we could do that, and the 5 ways are listed below. Okay, remember there's side, side, side. That's the 3 sides one. There's side, angle, side. There is angle, side, angle. Angle, angle, side. And of course, in a right triangle, hypotenuse, leg. So these are the 5 things that you have to show in order to have two triangles being congruent. Remember, there are 3 things that you need to show. One of these 5 different ways. Okay? So once you have the 3 things, you use the correct congruence postulates or theorem. Okay, remember, side, side, side is a postulate, angle, angle, side is a theorem. One of those 5 things once you have it. Okay, and that's what this says. If you have 3 congruent sides, then you use the side, side, side postulate. If you have 2 angles in a middle side, you use the angle, side, angle, and so forth. Okay, so depending on what your congruent picture looks like, you're going to be using different theorems or postulates. Okay, and this is what I tell my students to think about when they're trying to do a proof. These are your guiding questions. What information are you given? From your given information, what do you know is congruent? Okay, from the picture, what else is congruent? Because usually number 2 won't be enough. You have to get the 3rd thing or the 2nd and 3rd things from your picture. And then of course, how do you finish it off? What theorem matches your congruent information? Okay, and here's a little hint down here. Make sure to mark the picture as you find congruent things so that you have an idea kind of what kind of stuff you need to show. Okay, whether you need to find a 3rd angle or another side or something else. Okay, so what information are you given? From your given information, what do you know? Go to the picture to find something else and then finish it off. Okay, so I'll talk about these every single proof, because we're going to use a 2-column proof with statements on the left side and reasons on the right. Okay, so this is not a flow or a paragraph proof. This is a 2-column, pretty formal proof, geometric proof. Okay, statements on the left, reasons on the right. Okay, so we're given that C is the midpoint. So C is the midpoint of some segment JN. Okay, we always write down your given information first. C is the midpoint, and I'm going to shorthand midpoint MDPT. C is the midpoint of JN. So the first statement is always just what are you given? And the reason that you can write it down is because it is given. Okay, and the second one, I'm going to use the second line for the other given, that JE is congruent to EN. Okay, that is also given. Usually, sometimes, depending on how you're feeling, you don't have to start off with both givens at the beginning. You can include one somewhere in the middle as you use it. But here, we're going to start off with the givens at the beginning. So let's mark this. We'll mark that JE is congruent to EN. That's one of your givens. And that C is the midpoint. Okay, so here is guiding question number 1. From the midpoint, because you know that C is the midpoint, because you're told that C is the midpoint, what do you know? Well, you know that this segment is the same as that segment. Okay, midpoints make equal segments. So from your given information, from the fact that we have a midpoint, we know that JC is going to be congruent to CN. Okay? That's what we know, and the reason is the midpoint definition. Okay, we define a midpoint as being equidistant from 2 ends. So because we have a midpoint, you have congruent segments. Okay, so we can write that these 2 things are congruent by the definition up here, definition of a midpoint. Okay, so let's see. This is a side, this is another side. Okay, so now that we've exhausted our given information, look at your picture. What else do we know? What other congruent thing can we find from your picture? And I hope that you're seeing from the last video that both of these triangles share side CE. So we can, of course, always use a shared side. So this is from your picture. What else do you know? We know that side EC of the left triangle is congruent to side EC of the right triangle. Okay, and anytime we have the shared side, that's always the reflexive property of equality, in this case congruence. The reflexive property. And this is our third side. Okay, so fantastic. I have one side, two sides, three sides. I have three pieces of information. So I have enough. I have three things that is enough to say that triangle JCE is congruent, in fact, to triangle NCE. Okay, I have three sides of triangle JCE being equal to three other sides of three corresponding sides of triangle NCE. So these two triangles are congruent by the side, side, side postulate, which says if three sides are congruent, then your triangles are congruent. Okay, so this is a nice formal proof. We were given a midpoint. Okay, so we know congruent sides. We were given one other congruent side, and we found this reflexive side. Okay, so this came from our picture, and then we finished it off. We have three sides. Sorry. Okay, let's do another one. And now I'm given some parallel lines and one congruent line. Okay, that's excellent. So, statements on the left. Statement number one. AD is parallel to BC. Okay, that is fantastic. It is given. Wonderful. Okay, I am also given that side AD is congruent in length to side BC. Okay, so in this case, I have one line for each of my givens. Sometimes you could stack this and have two statements on one line. Really depends on how your teacher likes you to do it, or how you like to do it. It really doesn't matter. Whether you do one line, well, I guess it doesn't matter to me and my students. I don't mind whether they do it that way, but there might be some other ones. So I have that this AD is congruent to BC. Okay, I also know that they are parallel, so I'm going to mark that they're parallel because that's important. Okay, so question number 2. From your given information, from the fact that we have parallel lines, what do we know? Okay, so if you remember back, well, if you remember your parallel line postulates, if parallel lines are cut by a transversal, so here's a parallel line, here's BD is now your transversal, you have alternate interior angles are congruent. Okay, alternate interior angles are congruent, alternate exterior angles are congruent, corresponding angles are congruent, and the like. But in this case, we don't have any of those other ones. We have alternate interior angles. So because we have parallel lines, we know that angle ADB has to be congruent to angle CBD. Okay, because these are what type of angles? These are alternate interior angles. So by the alternate interior angle theorem, these two angles are congruent. Okay, so whenever you have parallel lines, you know you have congruent angles. Or you should know. I don't know if you know or not, but when you have parallel lines, you have congruent angles. Okay, so now question number 3. From your picture, what else do you know is congruent? Well, here I have this triangle on top and this triangle on bottom. Notice they both share side BD. Okay, this is the reflexive or the shared side. So I can say that BD is congruent to BD. Everything is congruent to itself. And which is really nice because in this case it's shared by both of these triangles. Okay, just like last time, this is the reflexive property. Okay, this triangle has a side BD. this other triangle has a side BD. Okay, whenever they share it, that side is congruent. Okay, so let's see, what do I have now? Let's go back and examine. So I have one side that was given to me. I found an angle because I had parallel lines, and then I had another side by the reflexive property. So sure enough, I have found three things. Three things is sufficient to say that triangle ABD is congruent to triangle CBD. Okay, once you have three things, well, three good things, I should say, not just three random things, but three specific things, you have congruent triangles. So looking at your picture, it looks like I have two sides, and the angle is in between them. So by the side angle side postulate, these two triangles have to be congruent. Okay, and you're done. Once you have your three congruent things, congruent side, congruent angle, congruent side, you have congruent triangles. Okay, so hopefully you're getting the hang of this now. Looking for the things that you need to look for. Write down your given information. From your given information, what do you know? Okay, this came from your picture, and you had enough information to say that the triangles are congruent. Okay, so in this case, if you want to, pause the video for a minute, write down this proof, okay, try and figure it out, and then come back and watch. Okay, I'm just going to carry on because you have the pause button. So if you want to pause, go ahead. So, of course, number one is write down the given. N is the midpoint, and I'm going to shorthand midpoint, MDPT, of BM and EH. Squeeze it all on one line, given. So N is a midpoint. So hopefully from number one, we know what to do with a midpoint. Okay, so from your given information, because we're not given anything else, and we want to show these triangles are congruent, from your given information, what do we know? So N is the midpoint of BM. So here's BM. That means this is the same as that. Okay? BN, segment BN is congruent to segment NM. Okay? And anytime you're using this, if you're given a midpoint, you're using the definition. So definition of a midpoint. It's what midpoints do. Midpoints make congruent segments. Okay, now what else? So now I use the fact that it's a midpoint of BM. Now I'm going to use the fact that it's also the midpoint of EH. So here's EH. That means that E to N has to be the same as N to H. So EN is congruent to NH. Okay, by the same reason, the definition of your midpoint. We've used the same thing twice. Okay, because it was a midpoint twice. If we only knew one segment, then we could only use one of these things. Okay, so we have exhausted our given information. We have two things. This is one side, and now I have another side. So now I turn to my picture. Looking at my picture, what else do I see that are congruent? And I'm going to say, these angles. I notice that these triangles meet at side N. So that means that these ENB and HNM are congruent because these are what type? These are vertical angles. So by the vertical angle theorem, the vertical angle theorem says vertical angles are congruent. Okay, so I notice that in this triangle, I have a set of vertical angles. Okay, so anytime you have this type of a picture, you have vertical angles, and vertical angles are always congruent. Okay, very frequently when you have a bow tie picture, you're going to have some type of vertical angles. So let's see, I have two sides and an angle, bam. I have three sides, or three things rather, not three sides, but I have three things, one thing, two things, three things. That is enough to stop and say that triangle BEN is congruent to triangle MHN. Okay, so not by side-side angle, of course, that's just the way I proved it. Looking at the picture, the congruent angle is between your congruent sides. So this is by the side angle side postulate. Okay, so the theorem or postulate comes from the picture. How does it look? Where are these things placed? Okay, not from the order in which you proved them. Okay, so even though I have side, side, and an angle in the proof order, from the picture, the angle that is congruent is between your sides that are congruent. That's why it's side, angle, side postulate. Okay, fantastic. You did excellent on that one. Okay, I have one more example before I turn this off. So my last one, once again, if you want to, pause the video, do the proof, come back and check it. So AE is a bisector, in this case an angle bisector since there are two angles. Prove that these two triangles are congruent. EKT, probably meant to say EKA. Sorry about that, typo. EKA and ETA. Actually, let me fix that right now. Sorry about that. Pause for a second. No, let me see right here. Here we go. Not EKT, but EKA. All right, there we go. So sorry. All right, back to the proof. So EKA and ETA. Okay, step number one, write down your given. AE is a bisector of angle KAT and angle KET. Okay, number one, reason is given. Okay, so angle bisectors. If you bisect an angle, that means we have two congruent angles. So up here, KAT got bisected, so that means that this side is congruent to this side. So angle KAE must be congruent to angle TAE. Okay? And this is what angle bisectors do, so this is by the definition of an angle bisector. Okay? If it says bisector in the given, you have bisector in the reason. Okay, so not only does it bisect KAT, it also bisects KET. So this one on the bottom as well got bisected. So when you bisect angles, you have congruent angles. Angle KEA, now this is the bottom angle, KEA, that's down here, is congruent to angle TEA. Okay, that's the one on this side, T to E to A. Okay, by the same reason, the definition of an angle bisector. Okay, so now I've exhausted my given information. Okay, I know the angle bisectors give me congruent angles. Now I have to look at my picture. This is the fourth one, so this should be fairly obvious that both of these triangles share side EA. Okay, and anytime they share the side, that side is always congruent to itself. So EA is congruent to EA. Okay, once again, that's the reflexive property. Anytime they share the sides, that's using the reflexive property, in this case, of congruence. And let's mark that on there, mark as we go. So I have three things, let's list them. The first thing is an angle, the second thing was an angle, and now I have myself a side. Okay, so I have three things. I have sufficient to say that triangle EKA, the triangle on the left side, is congruent to triangle ETA, triangle on the right side. Okay, so looking at my picture, I notice that the side is in between my angles. So this is, in fact, angle side angle postulate. Okay, even though I have an angle and then a side in my proof order, looking at the picture, the congruent side is in between the congruent angles. Okay, so placement of the congruence is just as important as the things that are actually congruent. Okay, so I hope this helps. There haven't been many videos that I've seen about triangle congruence, so hopefully this is a helpful one. And you can use these 4 guiding questions. Okay, what am I given? What information is given to me? From your given information, what do you know is congruent? Okay, once you've exhausted that, from the picture, you go to the picture. What else is congruent from the picture? Now we're going to have always reflexive sides, a reflexive side, or a vertical angle. Okay, this is almost always what comes from your picture. Reflexive congruent sides or congruent vertical angles. And then which postulate or theorem matches up from the picture. Okay, not the order that you prove them, but from the picture. Okay, and mark the picture as you go. So, wonderful. I hope you have a fantastic day and happy time proving triangles are congruent.